morning. I got two questions from Maya, Melissa, and Jay, and I'm going to do them before I start today's lesson. Thanks for your questions and keep asking questions, okay? The first question says we have two vectors, unit vector x. So this is question 15. We have two vectors, vector x, unit vector x, and unit vector y, and the angle between the two vectors, which is the angle between the tails, is 30 degrees. We need to find the resultant vector of 2 times unit vector x plus y. When I say resultant vector, I mean the magnitude of the vector and the direction of the vector, because vector is, all the vectors has magnitude and direction. That's what makes it different with scalar, okay? That's why it's different from scalar, okay? So how we do this? The first thing, I will draw a vector that represents 2x. So it will be a vector with a length of double 2 units, so this is 2 unit vector x. Then from the head of the first vector, you remember when we add vectors we need to put them head to tail, so I need to draw a vector that represents unit vector y from the head of x. We said that parallel vectors are with the same magnitude are the same, so I will draw a vector that's parallel to vector y, unit vector y. So this is a vector with a magnitude of 1 and parallel to vector y. So this and this are the same. Okay? Now I want to know what is this angle. So the resultant will be the resultant vector will be this green vector that connects, so this is R. This is the vector that connects the tail of the first and the head of the last, that closes the shape. So I need to know this angle. If I know this angle and I know that this is 2 units and this is 1 unit, I can use cosine law and find the result. Okay, we know that this and this are parallel, so if I draw vector u, y, which is this, it is 1 unit and this angle is 30 degrees. So if this is 30 and this is parallel, what will be the measure of this angle? They add up to 180, so this has to be 150 degrees. Right? This angle is 30. So this one is 150. Okay, now very simple grade 10 question. Magnitude of vector r squared will equal 1 squared plus 2 squared minus 2 times 1 times 2 cosine 150. Cosine 150 will be a negative number, so we just need to do this 1 plus 4. I have to minus, so I have to multiply those. 2 times 1 times 2 is 4 times cosine 150 is negative radical 3 over 2. Remember, use your calculator if you want it in this, but this is a special angle, 30 degree, 1, 2 radical 3, so this is radical 3 over 2 cosine of this. This is in the second quadrant, so it will be negative. Okay, we did this in advanced functions, but it is not our concern now. If you don't know, use your calculator. Okay, so 1, I just gonna 1 plus 4 plus 2 radical 3. Use your calculator, you will end up with 2.91 approximately. So magnitude of this vector, after I get the square root, sorry. So this will be, yeah, so r, the magnitude of r will be the square root of this, which is 2.9. Okay, now this is r squared, so the magnitude of r will be the square root. Okay, now I know that this is 2, this is 1, and this is 2.9, and this is 2, and this is 1. I can get this angle because I need a direction as well. So I will use sine law. So I will call this angle theta, and I will say sine theta over the opposite side, which is 1, equal sine 150 over the opposite side. So theta will equal sine 150 is 0.5, and because it's the same as sine 30, second quadrant, sine is positive. So theta will be sine minus 1, this. And that will be, remember we said that the calculator has to be in degree mode. So this will be like almost 9.9 degrees or 10 degrees. How can we express this? So we say vector r has a magnitude of 2.9, direction is 10 degrees or 9.9 degrees, with unit vector x towards the other question we did yesterday. Remember when we did minus y, it was here and the resultant was here, so it was off y, it was away from y. Here it is towards y, towards unit vector y. Okay, so this is how we do this question number 15. Okay, I hope you understand it. It's very important. The only trick, the difference is these two angles add up to 180. So this is 30, this is 150. That's it. Okay, now I want to do number 18. Question 18. We have a triangle P, Q, R. This is in the middle of, this is M and this is N. This, okay. They say that this is vector A. So PM is vector A, MQ is also vector A. And Pn is vector B. And Nr is vector B. Right? Yes. We need to prove that vector Mn equals 1/2 vector Qr. So the first thing I will do vector Mn. So what is vector Mn? Vector Mn equals vector Mp plus vector Pn, which is the same thing. Mp is the same magnitude as A, but the opposite direction. So minus vector A plus vector B. Correct? Yes. Now vector QR. This is the same thing as vector Q P plus vector PR. P is double the size of vector A and in the opposite direction of A, so minus 2A. And vector PR is double the size of vector B, so and in the same direction, so that's 2B. Now, if we factor the two out, we will get negative A plus B, right? But negative A plus B is the same thing as vector Mn, so that means QR equals twice double, or vector Mn multiplied by the scalar of 2. And that means vector Mn equals 1/2 vector QR. Okay, so this is how we prove number 18. Very important question, and thanks for asking this kind of questions. Okay, now I want to start a very short lesson, and I think the time will not be enough in this video, so I will continue in the next video, in the second video, but I will start here so I can use every minute. So, okay, the first thing is vectors, properties of addition. So what are the properties of adding vectors? The first property is which vector we start with doesn't make a difference. Vector A plus vector B is the same thing as vector B plus vector A. Doesn't make a difference. Or vector A minus vector B is the same thing as negative vector B plus vector A. So it doesn't matter which vector we start with, and this is called commutative property. Commutative property. Please remember those names because sometimes I ask multiple choice questions. I give you something like this and say name the property. Okay, so remember commutative. Doesn't matter which one you start with. The second property is if I have three vectors A, B, and C, it doesn't matter which two vectors I add first. So this is the same thing as vector A plus vector B plus C. So I can add vector B and C first, then add the result with A. Or I can add A and C first and then add B. It doesn't make any difference. This is called associative property. Okay? Still have time. Okay, 3. If I have a constant here, a scalar multiplied with the sum of the two vectors, if I add the two vectors and multiplying with the scalar, it will be the same thing as if I multiply the scalar with each vector and add the result of this. So I can multiply k with A, so it will be maybe 3 times A and 3 times B and add the result. So this is called distributive property. Distributive property. Okay. The last property is if I am adding I cannot add vector with numbers with a scalar. So I have, even if I want to add it with 0, I call it the 0 vector. So this doesn't make any difference to the adding. So I can add 0 and it will stay the same. So those are the properties of adding vectors. First commutative, then associative, then distributive, then adding 0. Okay, I will continue on the next video. See you soon.